Hi everyone, and welcome to our next video in the tessellation series, this one on intricate regions. So for this video, we're going to be exploring how can I make a region that isn't just a simple shape? How can I make it something like this, a little fancier, right? So the first thing we need to figure out is, okay, how do we get this shape? Because not every intricate region will tessellate, right? We need to figure out where do we get this from to figure out the rules for which ones will tessellate and which ones won't. So looking at this, it was formed using an equilateral triangle. So how would we do that, right? I'm going to start with my equilateral triangle, and I'm going to figure out what did they do to make this happen. Well, to me, it looks like they cut out this piece, and then they transplanted it over here, right? But why there? Why did they do specifically here? Would it have worked if I had done it over here, or if I had done it over here? Does it have to be in that one specific spot, is the question, right? Well, let's see how it tessellates and see if that kind of informs us why it had to go there. So we have our original shape, and now we're going to use a rigid transformation to tessellate with it. So you'll notice they are rotating this original figure, the shape, to form my tessellation, which works. Let's examine the rotated version, the final kind of collection, right? And see why exactly is it able to tessellate when it does that. So I've got 6 triangles here, right? And what we're doing is I'm taking this piece out to move it over here, right? Or in other words, what I'm really doing is I'm taking away this, and I'm cutting and pasting, right? It's like I'm cutting into my shape and I'm pasting it on the other side. So here, away from here, right? But these have to be congruent regions. So whatever I do to one region, I need to do to all the other regions, right? So there's this big gap taken out of all of them because, to push into one region, it needs to take away from the other, right? To keep them balanced. And it does so by doing the same thing that our transformation did, right? If the next piece is rotated over 1/6 of the way, then they're all going to do that, rotating over 1/6 of the way. You see? But it's not always going to hold true. Let's check it out for a simpler shape, one that we can test out with some other transformations really quickly. How about a square? So squares, we can tessellate in lots of different ways, which makes them very convenient. I can tessellate with rotations or just translations, right? And I can do the same thing with triangles, except triangles need to rotate at some point, right? So I'm going to use this because it's a little more convenient just to look at the translations versus rotations. So in this one, I've translated it over, then down, then over, and that got me 3 copies, right? So if I was to change this by trying to take this piece out, pop it out, you'll notice it had to eat into the one next to it, right? It had to take away a piece of this one. And now this one also needs to go over there because I did that for the other one, right? So my final result is a shape that looks like this. So the piece I cut has to be pasted with the same translation that the actual tile is translating for, the tessellation, right? Now notice the same thing if I was to do, say, a cut downwards, right? If I wanted to take a piece out here, I would need to take it out from the top too, and we'll examine why. When I go downwards, I have to eat into, right? I'm eating into my next one, like that. It's cutting into it, so I need to go down the same amount, because I did that before, and then also needs to take that much out of the top. So in this case, it might help more to see it as, if I take it away from the top, I need to take it away from add it to the bottom. Cut and paste, right? Notice my final shape is going to have some spiky bits and some bits taken out, like so. And then I can do it for my orange. I'm going to copy my bits in the middle too. So that would be my final shape, right? Not the prettiest of shapes, but it would tessellate. Now what if we did this for rotation, right? So I'm going to start with my original square, tessellate it. That's not a square. Tessellate it. But this time I'm rotating 90 degrees each time to go around. So when I do rotations, right, if I was to take away that piece, so I'm going to take away this piece and add it there, right? Where does it need to go? Well, when I rotate it, this piece ends up down here, you see? And I rotate it and it ends up over here for this one. And then for this one, it ends up here. And look at that, I already have a working tessellation because I can see the parts I need to take it away from the other one, right? It automatically clicked together like that. So when I rotate, the outer edges stayed nice and easy, right? But the inside stuff, I can mess around with the inside very easily. And you'll notice I rotate 90 degrees on the outside, I do the same thing on the inside. The transformation is cut and pasted after a 90-degree rotation around my center. So in other words, the rules to change the shape in order to make it work and still tessellate is just to use your changes and tessellate those, the inverse of them, the same way, right? Transform them the same way. So if I cut it from somewhere, I need to paste it with the same transformation I would use to tessellate it, and that'll work, right? So basically you just have to pick the way you want to tessellate first and then change your shape accordingly. I hope that helps you understand how to check if an intricate region can tessellate and to make some of your own, right? I would mess around and try to figure out what are the different transformations I can use to tessellate triangles or hexagons, and then you figure out some of the rules based on those for the transformations. All right. Hope this video was fun, and I hope you have a great day.